All right. So a correlation, we're talking about seeking correlation here. A correlation is a special type of relationship between variables in which a rise or fall in one goes along with a corresponding rise or fall in the other. A correlation exists between them when the higher values of one variable are consistently associated with the higher values of another variable, or when the higher values of one variable are consistently associated with the lower values of another variable. So there is a correlation between the variables. Height and weight for people. That is, taller people tend to weigh more than shorter people because they have more bones, right? Larger bones because they're taller, they're going to be longer. Whereas a short person's going to have shorter bones, so that alone. And then as you're shorter, like if you have less bones or shorter bones, then you're going to have like shorter muscle and all of that. So it's not always the case, but typically that's what we see. There's a correlation between practice time and skill among piano players. The more you practice, the more skill you will have. So those who practice more tend to be more skilled. Same thing happens in a math class. The more practice you do, the more skilled your math skills are, right? So practice so that you have good skills. All right. The graphs that we use for these are called scatter plots. And a scatter plot is a graph in which a paired sample data values are plotted as points with values of one variable on the horizontal axis and values of the other one on the vertical axis. So if we suspect that one variable depends on the other, we'll call that the explanatory variable. It means that it helps explain the values of the other one. And on the horizontal axis, and we'll put the response variable, which is responding to the change in the explanatory variable, on the vertical axis. There are properties of the correlation coefficient of R, and the correlation coefficient of R is a measure of the strength of a correlation. Its values can range only from -1 to 1 inclusive. So, the types of correlation we can have are positive. That means both variables tend to increase or decrease. The correlation coefficient is going to be from 0 or greater than 0 up to and including 1. Negative correlation, the two variables tend to change in opposite directions, with one increasing while the other decreases. This will be from a -1 up to, but not including 0. So less than 0 still, but going all the way down to -1. Now, no correlation means there's no apparent relationship between the two variables, and R is going to be close to a 0. Nonlinear relationship means the two variables are related, but the relationship results in a scatter plot that does not follow a straight line pattern. All right, so let's look at these graphs, and I have them a little bit bigger and in color on this paper. All right, so a weak positive correlation between our two variables here of x and y. It's kind of looking like it's going together, but it's kind of weak. It's kind of going at an angle. Now this one is more stronger, so these are kind of still spread out. These are getting closer together, so this is a strong positive correlation. This one will be a perfect positive correlation because it's all lined up in a line. This one is kind of going downward. It is a weak negative correlation. This one is a strong negative correlation because they're getting a little bit more close together, and this would be a perfect negative correlation. Now, there are some values. If you'll notice here, there's an R equals 0.3. So that's our correlation coefficient of R. It's closer to 0 here because it's weak. This one is a 0.7, so that means it's a stronger correlation value. It's closer to 1. And a perfect one will have an R value of 1. Now this one's negative. It's still spread out. It's kind of the flip of this one. And so it has a negative 0.3. This one has a negative 0.7. And this one has a negative 1. So these kind of give you an idea of what that will look like. This one has no correlation at all. There's no correlation here. And this would be a nonlinear relationship. We can kind of see these. This is not a line. This is more like a parabola, right? An upside down parabola, but still. So this is not linear. Mostly what we're going to deal with here are going to be linear ones. All right. So that's you have the same scatter plots on your handout, but I figured that would be helpful. So the coalition coefficient is a measure of the strength of the, oh, we already have that. All right. That's already listed on the top of the other one. All right. Apparently I moved it. So calculating the correlation coefficient. So there's a big old formula for that, but we're not going to use the formula. But I wanted you to see that you'd have to, that's a summation, and this is x minus x bar, so that's going to be a mean there, and a y bar, you're going to have to find the other mean, and then your, yeah, there's a lot of stuff going on in there. We're not going to use the formula. Instead, there's a couple of things you can do. So you can use Excel, you can use StatCrunch, Desmos, or a TI-8384. I've typed out the steps for a TI-8384 for you, and I'm going to show you how to do that. And I also told you about Desmos. So for Desmos, you go to desmos.com, and then over here in there's a 3-line icon that'll look something like that up here in the top corner of the Desmos screen. And you click on that 3-line icon on that top left, and a whole option will open up, and you will click on choose statistic linear regression, and then click open graph, and then you'll put in the x and the y values, and then once you put in those values, the x or the graph and all the information will appear. Because I know that all of you won't have access to a TI-8384 where you're at, but you can use the Desmos.com. It's actually even easier to use that than the graphing calculator. All right, so for each pair, we're going to state whether you believe there is a correlation between the two variables. And you're going to explain what your choice or why you're choosing that. All right. So the distances, oh, and I did have a picture of the icon. I just didn't put in the handout. That's what it looks like right there. That's an actual picture of it. A 3-line thing. Okay. And we'll talk about the TI-8384 steps here in a minute when we do that. All right. So the distances of taxi cab rides and the cost of the trip. Is that going to be a positive or a negative or no correlation? Well, the distance of the taxi cab ride, how much it's going to cost. Well, the longer I drive in my taxi cab, the higher the cost will be, right? So for, and this is 7.1, example 1, part A, if as the length of the trip increases, what happens to the cost? So as my length of my trip goes up, so we're talking about an increase, the cost increases, right? So they both go up. So if they both go up, then that's going to be a positive correlation. Positive correlation. They both went up. All right, let's look at B. The weights of gasoline-powered cars and the distances they can travel on a gallon of gas. All right, so the weight of the car and how far you can go on a gallon of gas. So as the weight of the car goes up, so as the weight goes up, what happens to my gallon of gas? So the mileage, right? How far we can travel on a gallon of gas. What happens to my mileage? My mileage will goes down, right? The heavier the car, the more it's got to pull. So it's going to go down. So this will be a negative correlation. Okay. All right, let's look at C. So C is the pulse rates and SAT scores of adults. So these are my scores versus my pulse rate. Does that have anything to do with each other? Does one go up because the other one did something? These actually have nothing to do with each other. There is no correlation here. Now, your pulse rate might go up a little bit while you're taking that, but this is looking at the results, right? There's going to be no correlation between your pulse rate and that. Now, if they were talking about running and your pulse rate, well, if I'm running, the more I run, the higher my pulse rate would go. But your SAT scores, not the test, but the scores, and your pulse rate won't do anything. All right, let's go on to example 2. The scatter plot shows the actual high temperature for the day is compared with a forecast made 2 days in advance. Estimate the correlation, correlation coefficient, and discuss what the data implies about weather forecast. Do you think you should get similar results if you made the scatter plot for a longer time period, such as a week or a month, and why or why not? So you have a picture of the graph on your handout, but I'm going to put a more colorful one. So if we're looking at this, we can kind of guess at what's happening with our coefficients, right? Remember, at the beginning, we were looking at some estimated correlation going on here. So we can kind of use that information a little bit here and kind of compare what's going on with these. So, and I see I have too many zeros in my answer in my notes again. So the coefficient or the correlation here, and this is an estimate. We haven't looked at precisely how to do it yet, but we have a coefficient here of correlation. It's kind of grouped together. There's a few little outliers going on, but for the most part, it's hanging in there. So we would say that this is it's reasonably accurate for these 2 days. So we're going to give we're going to estimate that coefficient as R equals to 0.7 off of the one that had a strong correlation. We think it's a strong positive. It's very similar to this graph. So it's a strong positive. And so we're going to do the 0.7, and we're going to say that it's reasonably, so forecasts are reasonably accurate. For 2 days in the future. Now, as we get further out, it's going to get weaker. The further into the future you go, the weaker the forecast will be. So when they ask the question about do you think you would get similar results if you made this for a longer time period, such as a week or a month? I would say no. because they're going to get weaker. We would expect the correlation to become weaker. Sometimes you might hear the weathermen talking about, we'll know more about where it's actually going to go when we get within like 2 days out. We can anticipate now, but we won't know for sure for a little bit because it's more and more difficult to see what the actual is going to do. All right. So let's go on to example 3. For example 3, we're going to, for the tables, we're going to find the following. We're going to construct a scatter plot, and we're going to find the exact value of the correlation coefficient. All right, so we need our graphing calculator. So I'm going to do a second. I don't want to change everything. So, all right. Good, everything's cleared out. All right, so we're going to use our calculator here, and we're going to follow the steps that are right here. We're going to use our data here, and we're going to construct a scatter plot. So the first thing we're going to do is we're going to click on our Stat button, and then we're going to click Edit right there, and we're going to hit the Enter key. So Edit is the number 1 there. Trying to get out of the glare. There we go. So we'll hit Enter. And if you want to clear them, if you come up to the top, I can hit Clear. Let's see. Okay, good, it cleared. I'm going to come over here. I'm going to hit Clear. Do not hit Delete. If you hit Delete, it will delete the whole list, and then you'll be in trouble. So don't hit Delete, but you can hit Clear, okay? And Clear is right here below the button. So I want to clear out my points. All right, so now what I'm going to do is I've got this. I'm going to enter my data. So I've got a 2, and hit Enter, and then a 3, Enter, a negative. For the negative, you've got to use the negative sign, not the minus sign. So a negative 2, a 0, and a negative 3. And then I'm going to use my arrow key, go over to the second list, and put 11, excuse me, and 13, and negative 1, and 6, and Enter, and negative 5, and Enter. So now I have my list. Make sure your numbers are all in correctly, because it'll mess up if you don't. So then it said, enter the data points, click second, and the mode button. That gets you to second quit, because that's what controls the blue buttons. So second and mode gets me quit. Now I'm going to click the second button and hit the Y equals. You need to make sure that plot 1 is on. So I'm going to hit Enter. I've got it on. And then I want to make sure it's on scatter plot right here. I've got my list for X is L1. L2 is there. I'm going to use that box to do it, to show my line. You can use the other ones, but the box is probably the easiest one to see, and in my case I have it as blue. All right, so I've made sure all of that's on. So now what I'm going to do is go over here and hit my graph button, and I can see my graph. Now I have in my data, I have 1, 2, 3, 4, 5 data points, but I only see 1, 2, 3, 4 data points. So now we've got to go to our window, and in our window we've got to include more of what's going on in our scale here. So My x min, I've got to have up to -3, but mine's currently showing only -2.5. So I'm going to go with -4. And then my max on the x is, it's 3.5. I'm going to take it down. I'm going to make it 4 as well. And then for my y min, I need to have at least a -5. So actually, why don't we just, yeah, that'll work. Okay, so we'll go with like -10. Or I guess we'll go with like -6. That'll work. And then for the max y, I'm at 13, so I'm probably going to go to like 14. I just want to make sure I'm going above. And I want it to kind of include all the points, but not too far out. All right, so once I have done that, then we'll go back to the graph. I can see all my points. Now, you got to decide, what does your graph look like? Does it look like a line? Does it look like a quadratic? In this case here, it looks like it's a line. Now, we're going to go turn on Diagnostics, and to do that, we're going to go to the catalog. The catalog is right down here at the 0, and it's blue, so I've got to do second and hit that 0 key, and it goes to catalog. And I want to find Diagnostics, so I'm going to put in the letter D, which is right here. So I'm going to do the alpha button, because that's my alphabet, and then hit D. Did it go there? The alpha, D. There we go. And then that way I don't have to scroll through everything. And now I'm looking for Diagnostics, so I'm going to scroll down. Oh, and there's my Diagnostics. I want to click on the diagnostic on and hit enter, and then it pulls up my enter. So hopefully you guys could see that, because I was showing you down here and I forget. All right, so let's go back. So let's go up. Go off. Let's turn us back on. Here, oh, it's going to go right back to it. I was trying to go back to the key. So second, quit. No, it's not going to, because I'm in the middle of a program change. All right, so we're going to hit enter again until you hit done. And then, all right, now I should be able to clear. Let's just clear it. So let's go back to the catalog. So second, 0. And then we're going to hit the alpha and the D button. I wanted to make sure I show you everything I wanted you to see. So diagnostic on, when you're at that one, hit the enter key, and you'll see diagnostic on come on, and then hit enter till you get done. All right, now what we'll do is we'll clear that. Now, to find the regression, we're going to go hit stat, and then we're going to go over to calc. So we use the arrow button to go over to calc, and then we're going to do linear regression A plus BX, or AX plus B. Sorry, there's 2 of them. You want the AX plus B, so number 4. It's kind of like Y equals MX plus B, so AX plus B, so we want number 4. I just hit number 4, or you can tab down either way, or arrow down. And then we're going to, you can, if you hit that, and then we're going to enter. So our list 1 is here, our list 2 is there. We're just going to scroll on down to the calculate, and we're going to hit enter. Now this is where it gives us our information. So we have a Y equals AX plus B line, because that's the type of data we had. Our A is equal to 3, our B is equal to 4.8, and this gives us our R squared value and our R value. So our R value on this is pretty close to 1. It's 0.99. So that's pretty close. This allows us to write the equation of our line. because we want to find the exact value of the correlation coefficient. But this also would allow us to write the line, which we will be moving into later on. The 3 would be our A, and the B would be our 4.8. So we'd have y equals 3x plus 4.8, which we would round the 4.8 to 5. All right? So that's our coefficient there. And then to graph the equation, we can click our y equals and then plug in the values that we're seeing of 3x plus 5. That's something we're going to be doing down the road. You don't have to do this now. I'm going to go ahead and show you now so that you know how to do it. When we get into best fit line, we would go to y equals and put in the 3. The x comes from here, plus 4.8. We're going to round to 5. And then we can hit graph. And that's not something you're doing in this section yet, but it will be coming up. So that's what we'll be looking at when we start talking about the line of best fit. But we have our scatter plot, and we were looking for the R coefficient. Now, if you put it into Desmos, this is how I put it into Desmos. You'll have a chart that looks like this in Desmos. So here's your X values. Not sure why those are underlined. Have no idea. And then here are your Y values. So I just changed the height. Instead of going across, I went down. And not sure why those underlined, but that's okay. We're going to use the steps in Desmos to do it. And this is what the Desmos graph looks like. So it'll have the green circles on it, and you can again change up the view to see it. And the R coefficient you get, whether you use it in Desmos or on the calculator, is R equals 0.994. Okay? So now, that is part A. Let's go do B. So we're going to go to the Y equals. I'm going to go ahead and clear that out so that line doesn't show up. I'm going to go back through my steps. So I'm going to quit that, go to my stat, and hit enter. Now I've got to adjust my numbers. So over here, I still have a 2, a 3, a -2, a 0. I just need to change the -1 and then hit enter. And over here, my 11 becomes a 6, and if I just type in 6 and hit enter, it'll change it. So you don't have to clear it beforehand. And then 14 and hit enter. And then -14 and hit enter. And -5, hit enter. And -10 and hit enter. Okay? And then, so I've put in my data. I've already turned on the diagnostics, so I don't have to do that again. Let's go look at our graph. Again, I can't see what's going on here because my values have changed, right? So the top, the X values are probably pretty close, but my Y values have increased. Now, one of the things you can do is go to Zoom. Instead of changing your window, you can go to Zoom, and the number 9 is Zoom Stat, so you can either scroll all the way down or hit 9, and it will fit the window to your thing. So Zoom Stat will get you there. Okay, so Zoom and then going down to Stat instead of going to Window and changing all the values. I can go to Zoom, hit number 9, and all my values will pop in. And we could have done that one on the first one, but I want you to know some options. So what kind of graph does it look like we have? It looks again like we have a line. Now, I still have to go find my correlation coefficient. So I'm going to go back to Stat button, and then I'm going to go over to the Calculate, and then I want number 4 again, linear regression, AX plus B, and then I'm going to scroll down to Calculate. So this time, here is my A, my B, my R squared. I want my R again, 0.99, that 9, we'll just call that 0.995, okay? All right, so let's turn that one off for a minute. All right, so let me go write some information down for you. So this is example 3. So we constructed the scatter plot first of all, and then we found the exact coefficient. So for A, our R factor was 0.994, and for B, our R was 0.995. Now, it's not always going to be that close to being a 1. It's just the numbers that I chose because I wanted us to see a good line. All right, so for example 4, listed our systolic blood pressure measurements obtained from the same woman. So we want to construct a scatter plot, characterize the correlation in words, estimate or find the exact value of the correlation coefficient, and then comment on the correlation between the two variables. All right, so we are back to our Stat button. We're going to go to Edit. We're starting over again. And our list 1 is going to have 102, and then 101, and 94, 79, 79, and then over will be 175, 169, 182, 146, and 144. All right, so I've got my list in there, and let's go graph this. I can't see any of it, so I'm going to go to Zoom 9, and now I can see my data points. And if I did this in Desmos, it looks the same. I've got the same graph going on with the 2 points down here and the 3 points up there. All right, so I can look at that. It appears to be kind of a positive going up there, right? It's a positive correlation because it's kind of going up there. Now, they're not super close to exactly the line, but they're going up there. It's still a positive correlation. But the way we'll even be able to tell is looking at our R factor. So let's go back to Stats, and let's go to Calculate, and let's go to number 4, and go down to Calculate, because that R factor is going to tell us just how strong is it. We have an R factor of 0.867, so with that R factor, that's telling us it is definitely a strong positive, right? So let's write some answers down here. So this is example 4. So for example 4, we did the scatter plot. In words, so this is number 2, I'm going to say this is from the scatter plot, right? So characterize the correlation in words. It's a positive correlation. On number 3, it said to give us the estimate or to give the correlation coefficient. So it's 0.867. And then for number 4, it says comment on the correlation between the two variables. Well, if it has a strong positive correlation, and what we were looking at was the blood pressure from the same woman in her right and left arm, there's a strong positive, because of the R, there's a strong positive correlation. So the value of R suggests a strong positive correlation. So if we look at the data there, as her right arm is at 102, it's at 175. At 101, it's down to 169. As it goes down to 94, it's up to 182. 79, it's at 146. 79, it's at 144. So it tends to go down, right? As the right arm goes down, the left arm tends to go down, right? The 182 throws it off just a little bit in that correlation looking, but sometimes you're going to have those in your data, right? So we would say that if the pressure, if the pressure, or the blood pressure, let's be specific, increases in her left arm, her blood pressure in her right arm is also likely to increase. So if it goes up in one, it's likely to go up in the other. All right, so that's stating all of this in words. All right, let's go on to example 5. So with example 5, a physician finds that increasing the time spent exercising each week results in a lower resting pulse rate. Because this is a positive result, we say there is a positive correlation. All right, so does this make sense? Well, it actually doesn't. So a positive correlation and a negative correlation refer to whether two variables increase together or in opposite directions, not whether something is good or bad. And they're stating here that increasing the time spent exercising each week results in a lower resting pulse rate. Well, that would be good, right? Because it's a positive result does not mean it's a positive correlation. That's the key right there. Because this is a positive result, there's a positive correlation. And actually in this case, it would be a negative correlation because the increase in the exercise decreases the pulse rate. So let's write that out in words, right? So increase in exercise, and an increase in exercise means that it goes up, right? And then what happens, they're saying, is we have a decrease in pulse rate. Well, that means the pulse rate went down. If one goes up and one goes down, this is a negative correlation, right? It is not a positive one. It is a positive result that you can lower your resting rate, but it is not a positive correlation. It's a negative one because one's going up and one's going down. Okay, so hopefully that helps bring it to mind a little bit more. So let me clarify just one more time. When we did the second one, or this third problem, notice we didn't go back and graph the line. So when you're doing this section, you're not going to do step 4 on the calculator. We're only doing through step 3 and finding out the R. It's later on that we're going to do step 4. So I wanted you to know what step 4 did, so I went ahead and did it on the first one so you could see it. But we won't use step 4 on the calculator for a little bit. Okay? All right. Make sure you do your homework. Get the homework all done for this section. And then that way you're staying on top of that. And I will see you in the next video.